Hi, my name is Sarah Popenhagen. I'm a first-year PhD student at the University of Hawaii, Manoa. This poster presents research being conducted by myself and Dr. Milton Garces on rocket ignition detection using audio data collected by smartphones. The goals of this study are to identify unique characteristics of acoustic rocket ignition signals and to develop algorithms to detect near real-time rocket ignition in audio data collected by smartphones. Rocket launch monitoring with fast and accurate ignition detection capabilities is valuable for nuclear nonproliferation monitoring. Improvements in rocket launch detection and early warning capabilities are also valuable, and this work is relevant for important MTV research areas such as supersonic and hypersonic shock and delivery systems. The data used in this study were collected by a network of smartphones located 10 to 100 kilometers from launch pads at the Kennedy Space Center in Cape Canaveral, Florida. Audio data from 37 SpaceX Falcon 9 and ULA Atlas V rocket launches were collected at a sampling rate of 800 Hz, annotated and aggregated into a curated dataset. Time frequency analysis was performed to identify and label ignition signals for each launch and smartphone. We then identified unique acoustic characteristics of the ignition signals and used these characteristics to construct a preliminary algorithm for near real-time detection of rocket ignition. Here we see the normalized audio data from 5 smartphones during a Falcon 9 launch last August. The vertical red lines shown on these figures indicate the time at which the algorithm first detected ignition. Our algorithm was able to detect ignition successfully up to about 60 kilometers from the launch site, but its accuracy varied depending on the distance. In these figures, we see a typical result for smartphones 20 to 30 kilometers from the launch site. In the top figure, we once again see normalized audio data from the launch, with the time of detection indicated by the red line. In the lower figure, we see time frequency representations of the 3-second long signal identified by the algorithm, as well as the normalized audio data of those 3 seconds in the bottom panel there. Detection in this range is very high. Detection of the initial ignition signal is 82% accurate, and detection anytime during the launch sequence is 92% accurate. Moving out to the 30 to 40 kilometer range, we see a sharp decrease in detection accuracy. The algorithm successfully detects that initial ignition signal for only 29% of the devices in this range. Contrast that with the 82% from the previous range. Launch detection accuracy also drops down to 61%, which you can contrast with the 92% from the 20 to 30 kilometer range. At 40 to 50 kilometers, ignition accuracy is 19% and launch accuracy is 53%. As the distance from the launch site increases even further, the accuracy continues to drop. Our furthest successful detection was at 63 kilometers from the launch site. Beyond that, our algorithm did not successfully detect ignition at any of the devices. In conclusion, we've shown here that acoustic signatures of rocket ignition can be detected up to about 60 kilometers from launch. At 30 kilometer range, accuracy is very high, but false positives can occur. At greater range, accuracy drops quickly due to the increasing prevalence of false negatives. Our algorithm can also detect second-stage ignition and first-stage entry burn if the signal-to-noise ratio is sufficiently high, but the accuracy for these events is much lower than that for first-stage ignition. Our next steps in this research area are further aggregation and curation of our rocket launch dataset. New launches are occurring all the time, and we're adding those to our dataset as they happen. We're also currently working on applying what we've learned so far about rocket acoustics to further research into ignition and launch detection. Another thing we'll be working on going forward is applying machine learning methods to our rocket launch dataset. Thank you so much for your time, and please feel free to reach out to me or Milton if you have any questions. Thanks again!